Welcome back to Metric Conversion and Dosages. We'll be looking at oral medication dosages today. As you know, doctors prescribe different dosages and different medications for different medical conditions and for different patients. And medications may also be available in different concentrations or amounts. You should know how to calculate how many tablets, capsules, caplets, whatever, or what volume of liquid medication or supplement the patient needs. Now, in many clinical settings, a pharmacist will do the calculations and provide the medication, but even then, you should check the dosage yourself. When it is possible, you should administer a medication in the strength ordered. For example, if a doctor orders 500 milligrams of nabumetone and you have 500 milligram tablets of nabumetone, go ahead and administer one tablet. But maybe you only have 250 milligram nabumetone tablets. So in that case, you would have to administer two. What if you have a choice between the two? One 500 milligram tablet or two 250 milligram tablets? Well, the rule of thumb is that you give the least number of tablets possible. So you would administer the one 500 milligram tablet. There are two reasons to do it this way. One is that the fewer number of tablets you have to count out, the less of a chance there is for making a counting mistake. And the other is that most people don't take pills as a hobby. They prefer to take the fewest number of pills possible. The exception would be a patient who has trouble swallowing. Personally, I would rather take 5 tiny pills than one big horse pill, but I am the exception, so follow the rule. This is a worksheet that I use as an introduction to oral medication dosages. I'd like for you to get your copy, and as I work through this on screen, please fill it out yourself. If we were in class, I would be asking you to help me fill this out. So always show your work and check it against the given answers at the end of the worksheet. If you can't figure out how to make your work come out to that answer, contact me. All right, and once again, number 1 reiterates that it is almost always best to administer the smallest number of pills possible. So the order is for 750 milligrams by mouth daily. The pharmacy has two sizes of pills. There's a 250 milligram pill and a 500 milligram pill. So how many pills a day should you administer? Well, if you administer a 500 milligram and a 250 milligram tablet, then you would have your 750 milligrams, and that would be 2 pills. You could also take a 500 milligram pill and break it in half to get another 250 milligram piece. This would also give you a total of 750 milligrams, but we still consider that taking 2 pills. There are still 2 separate things to swallow. The other way you could reach 750 milligrams would be to take 3 250 milligram pills, and that would also give you 750 milligrams. However, you're not the one taking them, you're giving them to the patient. That's 3 things for them to swallow. The rule of thumb says 2 pills only, and actually, in this case, you're going to have a smoother pill for the patient to swallow. Usually when you cut a pill in half, it's not as rounded, and it can be a little bit more difficult to swallow. Let me make this a little bit bigger so I have a little more room to write. Okay, the order is for 50 milligrams by mouth twice a day. Each pill contains 20 milligrams. How many pills for each dose? We can use dimensional analysis for this. We want a 50 milligram dose. That's where we're starting. And each pill contains 20 milligrams. I could write this conversion factor, or this conversion ratio, as 20 milligrams over 1 pill. It would still equal 1, but this format is useful because it allows me to cancel milligrams, and I get, let's go ahead and do some more canceling here. 10 goes into 22 times, 10 goes into 55 times. So I have 5/2 pills, or 2 1/2 pills. Okay, so 2 1/2 pills each dose. How many in one day? Well, 2 times that. 5/2 times 2/1, 5. 5 pills. Let's move on to problem 3. The order is for 0.35 or 35 hundredths milligram of the medication by mouth twice a day. The oral concentrate is 1 milligram per 2 milliliters. How many milliliters will you prepare for each dose? Well, 0.35 milligrams is the order. So that's the prescription. We're going to start there. And now we have this ratio, 1 milligram over 2 milliliters. I've been referring to this as a conversion factor or as a fraction. A fraction, a ratio are the same thing, but a fraction tends to make one think of breaking something into parts and having part of that, whereas a ratio reminds you that for every 2 milliliters of this solution, you have 1 milligram of the medication. Since we can use that as 1 milligram over 2 milliliters or as 1 milligram under 2 milliliters, that's the way I'm going to use it. Because when I do that, I can now cancel my milligrams, leaving with milliliters for one dose, and that equals 0.70 milliliters or 70 hundredths of a milliliter. Moving on. The doctor orders 10 milligrams by mouth once daily. The oral solution is 2.5 milligrams per 4 milliliters. How many milliliters will you administer to the patient for each dose? I hope you have been pausing the video to try to work this out before I work through it, but just to remind you, pause the video now. And here you have the answer. You did not have to cancel where I did. You could have multiplied straight across and then simplified. Let's try again. I will pause briefly after I read the problem. You pause the video and try the next one. Try this one. Dr. Harvey orders 400 milligrams by mouth every 6 hours. The bottle contains 200 milliliters and the strength is 80 milligrams per 5 milliliters. How many milliliters will you administer for each dose? How many milliliters will you administer for the day? Here's how that question could be answered using dimensional analysis. It works. However, the goal of this class is not to make you an expert in dimensional analysis, but to make your calculations accurate and quick. So I believe that most of you will look at that and say 25 milliliters, if I'm giving it every 6 hours, that's 4 times a day. So I'm going to do 25 milliliters times 4 equals 100 milliliters, and I'm done. Rewind a bit and take a look at that dimensional analysis if you wish. Okay, number 6. The bottle contains 250 milliliters. But that's not the order. It is the first thing, but be careful where you start. The order is for 75 milligrams by mouth daily given in 3 divided doses. Okay, we need to unpack this one a little bit more. This is the order for the day, but it's supposed to be in 3 divided doses. So first we have to divide 75 by 3 instead of starting out our dimensional analysis. So 3 divided doses means it'll be given as 25 milligrams. And when you're talking about divided doses, usually what you want to happen is it's divided evenly into a day. So this would be every 8 hours. And now that we have our amount here for one dose, we can do our dimensional analysis. So 25 milligrams in one dose. Okay, we are giving a liquid here because it says we have 25 milligrams per 5 milliliters. We're going to use that information to form a ratio, a conversion factor of 25 milligrams in the denominator and 5 milliliters in the numerator. Taking this a little bit further, notice we're asking how many teaspoons of the drug we will administer. Okay, so we have to convert 5 milliliters to teaspoons. Okay, because 1 teaspoon equals 5 milliliters. And interestingly enough, everything cancels. So we have 1 teaspoon for each dose, given 3 times a day, 8 hours apart. I am going to leave number 7 as a challenge question for you because it is really a problem that we're going to discuss more fully in class 11. But give it a try. See if you can figure out how this next problem is different than the previous ones. I have some other things I wish to discuss with you. If a patient must drink 8 ounces of colonoscopy prep every 15 minutes for 2 hours starting at 1800 hours, when would he finish the 2 quarts that he was prescribed? Okay, what was he prescribed? 2 quarts. That's where we will start. Let's see, we need to get to ounces. So let's do 1 quart equals 2 pints. And 1 pint equals 2 cups. And 1 cup equals 8 ounces. And let's see, 8 ounces was a dose, right? So 8 ounces under 1 dose. And he took a dose every 15 minutes. And we need to talk about 1800 hours. This is getting pretty complicated, isn't it? Okay, so I think there's going to be an easier way for you to do this. Remember, we're looking for accuracy and speed, but accuracy being paramount. So let's take the first part of this dimensional analysis and let's calculate that. 2 times 2 is 4, times 2 is 8, times 8 is 64 ounces. Now I could have pulled a little more of that dimensional analysis down here because we're still going to have to divide by the number of ounces in 1 dose to find out how many doses we have. So that's pretty easy. 64 divided by 8 is 8. So he'll be taking 8 doses over that 2 hours. Now, let's think about this. Okay, he's going to start at 1800 hours. And every quarter hour, he's going to take a dose. He's going to do that 8 times. Well, 8 quarter hours gives you 2 hours, right? So if you add 2 hours there, he should finish at 2000 hours. Or does he? Let's make a chart. At 1800 hours, he takes the first dose. At 1815, he takes the second dose. At 1830, he takes the third dose. And he keeps going. And keeps going and going until he takes the 8th dose. Oh, but wait a minute. This says he's taking the 8th dose at 1945, not at 2000 hours. What's happening here? With our initial time, 1800, which is actually sometimes known as time 0, is when he takes the first dose. So it's not like we start counting 15 minutes after the time period starts. We start counting the doses at time 0. And then our first 15 minutes is up at 8:15. It's finished at 8:15. But we're giving our second dose then. So we only have, in that way, 7 points in time after 1800 hours when we're giving the doses. Anyways, the answer to this is not 2000 hours. It is 1945 hours. Be careful. The first dose is always given at time 0. This is one of the reasons I always suggest you calculate the time of dosages and the time components separately from your dimensional analysis. My Lab Nursing gives you more practice with this. I suggest you pay close attention to the online exercises that deal with military time. From military time, we need to turn our attention to milliequivalents. That is spelled this way, milliequivalents. And it's abbreviated M, capital E-Q, milliequivalents. So rather than expressing the strength of a liquid medication in milligrams per milliliter, sometimes the strength is indicated in milliequivalents, which indicates the amount of medication in 1 milliliter of solution. Here are a couple of examples of labels that tell you the milliequivalents. In the K-tab, on the K-tab label, the strength is listed both as milliequivalents and as milligrams. Let's take a look at this situation where we have potassium chloride oral solution at 20 milliequivalents per 15 milliliters. And let's take a look at this order that we might receive. Potassium chloride, 60 milliequivalents by mouth daily in 3 divided doses. So how much in one dose though? 60 milliequivalents divided by 3 will give us 20 milliequivalents. So one dose is 20 milliequivalents, but notice if you go over to our label on the potassium chloride oral solution, we find that there are 20 milliequivalents in 15 milliliters. So actually the answer to this one could have just been read off the package, 15 milliliters. If the patient needs 20 milliequivalents each dose, you're going to give 15 milliliters. And look, the container that goes with this label has 15 milliliters in it. So you would be providing the patient with one of these containers to drink every 8 hours. All right, you have an entire second worksheet going over these concepts of oral medication dosages. Please download that from My Lab Nursing as instructed. And if you have any questions, please contact me.